Hey, today we're talking about binomial distributions. So binomial distributions are situations where you have only two answers. Typically we classify them as a yes or a no, or a success or failure. So for example, if I ask you, do you like cats? That's a binomial situation because your answer is either yes or no. Now, if I ask you how many cats you have, that's not binomial because you could answer 0, 1, 2, 3, 4, 5, 6, 12. Those are all possible answers. So binomials only have a yes or a no response, or a success failure. Another example, do you believe in UFOs? What you do is you put yourself in the scenario of that question. You say, how would you answer that question? The answer is you'd say yes or no. Now, if I ask you how many UFOs have you seen, then that's not binomial because you could have any number of answers. Your blood pressure is not binomial. There's a lot of different numbers that you can answer. Anything that has a number range, which is what we've been dealing with, right? Like people's heights, people's blood pressure, how many objects they buy at the store, all of those things are not binomial. So usually it's a yes, no, do you believe, do you like this presidential candidate? That's a binomial, those sorts of things. So these operate, the problems will feel a little similar. We're still doing distributions. They're still going to be roughly normal in shape, and we'll talk about how and when. But there's a couple new notation letters. N is the same as it always has been, but that will be used here. This is the number of trials. I use the word trials in binomial. It's because we're pulling a sample and it's the size of the sample, but it's the number of, or like if you think about flipping a coin is a binomial situation. You're either going to get heads or tails. There's only two options. And so a trial would be like, how many times do you flip the coin? Or if you're surveying people, it's how many people you choose. P is another letter that we use. This is the probability of success. Now you get to dictate what success is. Success, typically we say success is like a yes answer, but in the situation of flipping a coin, it's not clear what a success is. So you get to decide. Like we're going to say that flipping a head is a success. Okay, a tail is a failure. And it doesn't matter which you decide because there's only two options, so that's all equal. And then Q is the probability of failure. Now, what I want you to realize in this is we're using this word probability again. So that means that P and Q have to be less than 1. Why? Because 1 is 100% of the time, and these problems are going to be like a 0.43. So say, for example, I could say 43% of Americans believe in UFOs. Okay, so first of all, you have to decide if that's binomial. Do you believe in a UFO? Yes. Okay, yes, no, that's a binomial. 43% is the probability of finding a person that does believe in UFOs. So that would be my P value. So one of the clues in these problems that you're dealing with a binomial is often there's a percentage at the beginning of the problems. Now that's not a given always, but often. So when I read a problem, if I see a percentage at the beginning, it's going to tell me some percentage of people think this. That's a big flag to me. Hey, this is probably binomial. So then I carefully go put myself in the problem, ask the question to myself and see if I'm going to answer yes or no, or if I'm going to give a numerical value, and then decide that it's binomial from there. Okay, so P and Q are going to be numbers like 0.43, 0.31, anything less than 1. All right. Now the mean of these distributions. In our normal distributions, in the beginning of this chapter, the problems would give you the mean and the standard deviation. They don't do that here. You have to calculate it. So the mean formula is N times P So it's the number of trials or your sample size times the probability of success. And your standard deviation is going to be the square root of NPQ. Also, your homework talks about the variance, which is sigma squared. That's just going to be NPQ. I will not ask you about that, but that's just for your reference if a homework question asks you about sigma squared. That's how you do it. Okay. This is where we're going to live, mean and standard deviation. Now, square root, where is that? If you're on a calculator on a TI, your square root button is right here. Okay, it's above the squared. It's this blue right here. So you're going to go second function and then that square root. There will be a little square root show up, and then you can do n times p times q underneath there. On class calc, your square root button is in the lower left-hand corner here, right next to the x, right there. That square root of a, that's your square root button, okay? So you type that, and then you can do your n times p times q there. All right, now these distributions are discrete because what we're doing is we're calculating the probability of the success rate. Okay, so let's take, for example, let's look at this picture and let's take, for example, we're flipping a coin. All right, so let's say a tail is a success. So we're charting that tails are successes. So if you look at this graph right here, n is 4. That means that I'm going to flip the coin 4 times. And when I do that, what I'm charting here is this is going to be the percentage of time that I have 0 tails. What I'm doing on that horizontal axis is counting how many times I have a success. So 30% of the time when I flip it 4 times, I'm going to have 0 tails. 40% of the time, I'm going to have 1 tail. 20% of the time, I'm going to have 2 tails, and 5% of the time, I'm going to have 3 tails. 0%, I'm going to have 4 tails. Okay, so that's how these are working. And you can see, because these are discrete, because I have a countable number of possible outcomes, these actually look more like histograms than that smooth curve. Okay, because if I'm flipping the coin 4 times, I've only got 4 bars. There's only 4 options. Whereas in the normal distributions, when we're talking about like blood pressure or something, there's all sorts of outcomes, right? So we can't make a bar for every one. It ends up being this smooth, continuous curve. But these guys are countable outcomes. Okay, so that's how the pictures work, the charts work. Let's look at what happens though. So here's n equals 4. I'm flipping the coin 4 times. Here's what happens if I flip it 10 times. Now notice NP is your average, right? Okay, so that's going to be 2.5. So right in here. Okay. And look at how that shape is looking a little bit more like our normal curve. Now let's jump up. If I flip the coin 25 times, now look at the shape of the curve. And then 50 times, this is a full-on normal distribution. So the idea that I want you to understand here is, first of all, these are bars on our chart instead of the smooth curve. But the more times that or the bigger your sample, or the more times you flip the coin, the more this is going to be looking like a normal distribution. So when we draw these, just for time's sake, we're going to draw a normal distribution, but we want to understand that we can only do that when our n value is high enough, okay? And which we will try to achieve, but that's the idea. Okay, so let's go and jump into these problems and what they look like. So first of all, you need to identify that this is binomial. That's the first thing that you're going to look for. And this is a big clue. Without even reading the problem, I go, oh, 72%. That says to me this might be a binomial. So I'm going to read the problem, and I'm going to try to figure out what's the question they're asking, and I'm going to ask it to myself. Okay, so survey says that 72% think that celebrities get special treatment when they break the law. So my question would be, do you think that celebrities get special treatment when they break the law? And your answer would be yes or no. That makes it binomial. Okay, so that's your first step is to identify that it's binomial. The next thing we're going to do is calculate our mean and our standard deviation. So the mean is n times p. Now, what I do with these problems, you can decide what p is going to be. I typically just take the percentage they gave me and make that p. So if 72% think that celebrities get special treatment, then that's going to be my p value. Okay, so p is going to be 0.72. And that means that Q is going to be the rest. Now, how do we figure that out? P is the successes, Q are the failures. Together, they add up to be 100%. So how do I find Q? I take 100% or 1 if I'm in decimal land, and I subtract 0.72. It's the complement. So remember in the probability section, we talked about at least problems. We talked about the complement of an event. The Q is the complement of P. And we always found that by going 1 minus. So if I do that 1 minus 0.72, I'm going to get 0.28. That's going to be my Q value. Okay. So the mean is going to be NP. So that's going to be you randomly select 14 adults. So this is going to be 14 times 0.72. So I'm going to get, this is going to be 10.08. Now for labeling purposes, I'm okay if you kind of round roughly. So if you want to call that 10 instead of 10.8 and not have all the decimals on your picture, that's fine with me. Okay. The sigma is going to be the square root of NPQ. So I'm going to go the square root of N, which is 14 times 0.72 times 0.28. And I get 1.68. So again, like you could call that 1.7 if you want to kind of make it easy on yourself. All I'm looking for in your picture is that it's roughly drawn correctly. Now, these are binomial distributions. Technically, this should be bars, but we're just going to draw them this way for sake of speed. So I'm going to call this 10, 10.8 median, and then this is going to be 1.7. So this is going to be 11.7 and 8.3. Okay, that's my one standard deviation away. And then we're going to do the problem very similarly to how we did the normal distributions. Above or below a certain mark, what's the probability? There's going to be one change. Okay, so let's read the problem. Find the probability that the number who say yes is exactly 8. So let's do that first. Okay, that means that here's 8. And remember, these are bars. So basically, I'm just asking you, what's the height of that one bar? All right, so what you're going to do on a TI is you're going into the same place that we have been. Second function, distribution. And you're going to scroll down past the window. So you have a couple options. Keep scrolling down. For me, it's option capital A, way down under. Okay. And it's called Binom PDF. Now, I don't know what PDF stands for, but what I have in my brain is that P stands for point. So when I want exactly one bar or one number of successes, then that's what you do PDF for. Okay, so if I'm asking what's the probability that I have exactly 8, that's just that one value, that's a point. So I'm going to go binom PDF. And when you select that on the TI, it'll give you a screen. and it'll ask you the number of trials, that's your N value. And then you'll ask you the P value, and then it'll ask you the X value. The X value is this is the one that we're interested in. This is the value that the question asks you about. So that's going to be 8 in our situation. P is going to be our 0.72, and the number of trials is going to be 14. Okay, and then you hit paste, and you should get your value. Let me get that for you. You can check yourself. Make sure you're calculating it right. And I get 0.10, let's call it 0.105. So there's roughly a 10 or 11% chance that you have 8 successes in this situation. Okay. Now, class calc. This is where class calc, I think, is so much better because it's going to draw you a picture. Okay. So we're going to the same place we've been going. We're going to stat, and then we're going to distribution and plot, and we're going to binomial distribution. Binomial dash dist. Okay, same deal. It's going to tell you next to that question mark what it wants. It wants N and P. So we're going to enter 14 and 0.72. Okay, and then just like the normal distributions over on the right, you have a choice between CDF and PDF, and you're gonna, again, we want PDF for point, that's 1 bar. But before you do that, I want to show you the picture. So hit the magnifying glass under your blue square, and it centers this distribution. So this is like the graphs we showed. And what's cool is it's in bar chart form. So you can see that your mean is about 10. That's the center. That's the value that we calculated. So good. We did that right. And these are all your bars. Now, all of them are filled in because you haven't told it what you want to check yet. But we want to know exactly 8, which means we want to measure the height of that 8 bar you can see right there. So I'm going to hit PDF. Okay. And it's going to say, okay, cool. What's your point? And I'm going to put in 8. Now look at what happens. Oh, I guess it doesn't highlight the 8. Okay, I thought it did. But here's another way you can, so look at your answer, 0.0145. That's the answer we got on the TI. So that's the probability that you have 8 successes. Now, if you look at that diagram, do you see there's a little gray dot on the top of each bar? Another way to do this problem is you tap on the dot above the 8 bar. See that? So you got 8 is 0.105, and you can do that instead of doing the PDF if you want. You can just tap on the bar you want. You want to know the probability of exactly 12 successes, tap on that gray dot on the top of 12. Okay, that's the quick way to do it. All right, so that's part A on this. Part B says at least 10. At least means 10 or more. This means 10 or more. So it includes the 10 bar and goes up from there. So if I was to draw a picture of it, it would be this bar right here at 10 and everything above like that. On class calc, it works very similar to your normal distribution. So you're going to come over here. Your binomial distribution is going to be 14 trials, N is 14, P is 0.72, and you're just going to put 10 in that left-hand column, leave the right-hand one blank. And you can see on the picture how it colors in 10 and up. So you can check yourself to make sure that the correct bars are colored. If by accident you put the 10 in on the wrong side, you can see that it goes 10 and down, and you go, oh, wait, that's not what I want. I want at least 10, which is more than 10. So you can make that correction. So that's the nice thing about class calc is you can check your answer visually and make sure you entered the right numbers. So our answer here would be 0.649. All right, now let me take some time and talk to my TI people. If you're on class calc, you can fast forward for a little bit. I want to make this part on the TI is a little complicated. So remember when we did inverse norm on the TI, we said, hey, here's your normal distribution. And when I gave you a problem, like say the top 10%, and you wanted to find this value right here, we said, hey, the calculator always measures from the left. So instead of entering 0.10, you have to enter 0.9 because it's measuring from that left-hand side always. The same is true on the TI for a binomial distribution. It's always going to measure from the left. So for this problem on a TI, if you have your 10 in the middle, and you enter 10 on your binomial distribution, what it will do is everything up to and including 10 because it's coming in from the left. So if you want 10 and above, you have to do 1 minus. So let's talk about that. If there's two parts to this graph, one's the purple part and one's the green part. The calculator, if you enter 10, the calculator is always going to give you that green part. Now, the green plus the purple is one whole. So if you know the green part, you go 1 minus the green part, and that's going to give you the purple part. Does that make sense? We've done that before. That's the complement. The purple is the complement of the green. So yes, you want to enter that number from the left, but then if you want the high side, you have to go 1 minus. All right, now I want to jump back to class calc so that you can see the picture and we can talk about what you're going to enter. So here's the picture of what's happening. We want 10 or more. So what you want to enter, if you enter the number 10 and go 1 minus 10, that's going to take away that 10 bar. So really what you want to enter is 9. You want to enter the first bar of that left-hand piece that you're going to subtract. So you're going to enter x equals 9. Let's look at it a different way. Let's draw a number line. Here are your options. You can have 0 successes, 1, 2, 3, 4, 5, 6, 7. I shouldn't have started at 0, but that's okay. Okay, and on up. All right. So I want 10, 11, 12, 13, 14, all the way up here, right? 10 or more. So if you enter 10, that's going to take this one and all of these. And then if you go 1 minus your x equals 10 value, that's going to give you the remainder, which is 11 and up, because you subtracted off the 10. And you don't want to do that. What you're trying to do is you're trying to preserve those yellow circled numbers. So what you're asking yourself is, if I'm on the high side of my distribution, what do I need to subtract off? Okay, that's the question you're asking. If it's something or more, it's what do I want to subtract off? No, I don't want to subtract off that 10 because 10 or more includes 10. I want to subtract off 9 and below. So really what I want to do is start at 9 and below. And then what's left when I subtract those off is the yellow. So for the TI in this situation, you want x to equal 9. When you go into binomial. So let's talk about how to type that in. So you're going to go second distribution. Okay. You're going to go all the way down past your screen. It's option B, I think. B says binom CDF. And when you select that, you get your screen. And it first asks for, hold on, let me go there. Trials, so that's your n value. Well, I'll write trials because that's what it says. So trials is your n value. I think we're at 14. Yep. Then it asks you for your p value. Remember, this is always a decimal less than 1. So 0.43. And your X value is what are we either counting, what are we including, or what are we subtracting off, depending if you're left or right tail. So in this situation, I want X is 9. When I do that, what that's doing is it's giving me the value of 0 all the way through 9. So the number you enter here on your calculator for X is the number that the calculator is going to go up to and through from 0, always from the left. So this is giving you, if this is our distribution, here's 9. This is giving you all of this area. Okay. And what we get is, wait, sorry, 14. Oh, I have a typo here. Sorry, it's not 0.43. It's, where's our problem? It's 14 and 0.72. Sorry about that. Let's change that. Oh my gosh. Hang with me. Here we go. Trials 14P is 0.72. Good. Okay. So trials 14, P 0.72, my X value of 9, that gives me 0.35. So that means on this picture, 0.35 is my yellow section. Now, I don't want that. I want the rest of the distribution. I want 10 and up. So what do? I'm going to take 1 minus 0.35. Because the purple part is the complement of 0.35. So I go 1 minus that, and I get 0.65. Okay. And that's going to be your answer. And if you go back up here to our problem, that's what we got on TI, rounded one more place. Okay. So it is significantly easier to do binomial distributions on class calc because it's straight up what you see is what you're doing. But you can do it. Okay. We'll do a couple more examples here and you'll get the hang of it. Okay. So let's do part C. Part C says, I want less than 5. Okay. So let's erase a couple things. Less than 5. All right, so that's going to be 5 is somewhere here to the left. Okay. So let's go class calc. Same N and P value. I'm already in CDF, so all I have to adjust this is now. Now, here's the great thing about class calc. Where are you going to put the 5? On the left or the right? I don't know. Guess. See if your picture matches. 5. No, it doesn't. Right? Because that's 5 and up. Do you see that? Now 4, you can zoom in if you want, if you can't really see what's going on. But you zoom in, these boxes are real flat. But you can see that these guys are empty and the ones that are filled in are the ones to the right. Okay. So that's not what I want. I want less than 5. Okay. So let's put 5 on the top side. Okay, so now that, can you see that 5 box has some color in it? That's 5 and under. Is that less than 5? Look at the language again. This says less than 5. That means that 5's not included. So what that picture doesn't match what I think it should be, right? I don't want 5. I want 4 and below. So I go, oh, wait, I didn't want that box on 5 colored in. So this has to be a 4. So there's this issue of like, is the number I'm naming included or not? If it's not included, then you have to go 1 or below or above, depending on if you're doing less than or greater than. If it is included, then you want that number exactly. Okay, so this is less than 5 is going to be 4 and lower. And it looks like we've got a couple zeros and a 9. Which makes sense with the picture, right? Because it's way in the tail, 0.0009. Okay. Now on class calc, you've got the same issue. You're going to enter, what do you want to count? Do you want to count 5 or do you want to count below 5? Oh, I want below 5. So actually for class calc, your X value is going to be 4. Now, do I have to do the 1 minus? No, because I'm already measuring from the left. So this is a left-hand tail. So I can go straight in and go, when I enter X equals 4 on the TI, that is going to count bars 0, 1, 2, 3, and 4. From the left up. Okay. Remember that you're counting bars. So the question is, do you want to count that bar or do you want to be at 1 bar below or 1 bar above? Okay. That's what we're trying to figure out if we're, for what number we're entering. So TI, inverse distribution, binom, CDF, and you're going X equals 4, and that'll give you your answer. Okay. What if we had, at most 11. So what is the probability that we have at most 11? What does at most mean? Okay, so at most means that 11 is our maximum. That means that I can go up to 11, but not over. Now you have to ask yourself, is 11 included? Yeah, at most 11, that implies that 11's okay, just as long as I don't go over. So 11 is included and I want anything under that. Okay, so for my class calc people, you're actually going to enter 11 because I'm okay including 11. Whereas before, when I said less than 5, that means don't include 5. So you got to drop it by 1. My TI people, you're measuring from the left, so you don't have to do your 1 minus trick. But what do you go up to? Do you go up to 10 or 11? Well, you want to include 11? Yes. Go up to 11. So this is going to be X equals 11. So if we want to look at a picture of this, here's my distribution. I'm going up to 11. So see how that 10 bar and the 11 bar are included. They're colored in. That's at most 11. So that's going to be 0.797. Okay, we will do some more practice with these vocab words in class, the at most, less than, more than, and talk about this 1 minus thing. We're going to do a lot more practice with this. This will just get you started, get your feet wet, and we'll do some more problems when we get into class. All right, talk to you later.